Hey there guys, this is Elixir and welcome back to this Elixir Programming Language tutorial series. So in the last video, we built a very simple calculator app which took a string for an input and it split the string to find out what operation is to be performed on numbers, and after finding that out, we performed the operation and printed the result to the screen. So if you remember, in the last video, I did tell you that we'll be looking deeper into how Elixir uses Erlang virtual machine. So we're doing this very early in the series. I told you we'd be doing it later, but the reason we're doing it early is because it is always good to know all these behind the scenes execution stuff when you're in the initial stages of learning a language. Because in the later stages, when you're working big time with all this understanding, you're always going to have troubles. So that is how I go about learning any language, and that is exactly what I'm doing here. So let's go ahead and understand a little concept. So first of all, you have to understand that Elixir was inspired by a couple of languages. The syntax of Elixir heavily resembles Ruby. This is because the person who created Elixir was from Ruby community. Ruby, as we all know, is very simple and it has very simple syntax. So Joost Walem, the guy who created Elixir, thought that it should be as simple as that, and the syntax and all that stuff is inherited from Ruby. And the execution part, for that, it is directly inherited from Erlang. And that is why, it has a lot of power. We'll look into that later. And there are a couple of other traits such as protocols and macros, which are, derived from languages like Clojure. So Elixir practically takes up all the good points from this language, and that's why maybe it is so powerful. So we'll go ahead on understanding how Elixir uses ErlangVM. So we'll start from creating a file. So I'm going to create a file called fact.ex, and in that file I'm going to define a module called Factorial. So yes, I'm going to be writing a logic for finding out the factorial for a given number. And the reason I'm doing a factorial logic is because it can be done on different ways using the different data type available in Elixir. So in the future videos, we can compare it for efficiency. For now, I'm just going to take the conventional, recursion approach. So here's my get input function. So I'll declare a variable called input number. So we get the input using io.gets. So I'll say enter the value of n. And if you remember, we have to get rid of the trailing new line character. And in this case, we also have to convert it into an integer because we want it as an integer in the initial stage itself. So we'll use the toInteger function from the string module. So once we do have the input number, I'm going to pass it on to a function called find factorial. So one of the argument it is going to take is a number, and I'm going to pass another argument, a number, which is 1. So I'll tell you the reason as I write the logic. So let's go ahead and write the find factorial function. So the first parameter is the number, and the second parameter I'm going to call it as a product, because that is what holds the result of multiplication. So what I'm doing is, if I find that a number is equal to 1, then all I have to do is I have to output the factorial value, which is in the product variable. If the number on the other hand does not equal 1, I'm going to call this same find factorial function, but this time I'm going to reduce the number by 1 and I'm going to multiply the product by the number. So let me give you an overview of how this works. So suppose I'm giving a value of 3, so I want to find the factorial of 3. So the first time it enters a find factorial function, the parameters, the number will be 3 and the product will be 1. So 3 is not equal to 1, so it will go again into the find factorial function, but the parameters now will be, the number will be 2 and the product will be 3 into 1 3. So 2 is still not equal to 1, so it is going to go again into the function. So 2 minus 1 becomes 1 and 2 into 3 becomes 6. So when the number is finally 1, you can see we have the factorial value. We multiplied 1 2 and 3, which is 3 factorial. So this is the logic that I am following. So let's open up a terminal and let me fire up IEX. So when you do fire up IEX, you see the Erlang OTP and its version. So just keep this in mind. We'll look at it later. For now, we'll just go ahead and compile our file. There is an error. The number is not defined. Why is the number not defined? Yeah, so here it is, input number. Yeah, so now you see we have the factorial module that we defined available for use in IEX. So I'm just going to go ahead and call the get input function from factorial module, and when I say 3, you see 6. And just to give you the recognition of Elixir's power, I'm going to enter a very big number. So I'm saying factorial of 1000, and you see this number seems to be the factorial of 1000. So this is raw power actually. So we'll see how this happens. I mean, how is Elixir able to do such a big calculation in a very short time? So yeah, so first of all, again, as far as Elixir and Erlang is concerned, or you can say as far as Erlang virtual machine is concerned, it does not care what the language is. It can be Elixir or Erlang. In the end, when it's a compiled down, it is compiled down to Erlang bytecode. So the takeaway from this is that Elixir is a language which is built on Erlang, and you can call the Erlang syntax in Elixir or Elixir syntax in Erlang, but as far as the interpreter or Erlang virtual machine is concerned, it is just a Erlang bytecode. So we'll have a look at that. So I'm going to do elixir C, which stands for elixir compile, and I'm going to give the fact.ex file as the argument. And this is not a recommended way of compilation. The good method is opening up IEX and then compiling, but this gives you a look at the bytecode. That is why I'm doing this. So now you see there's a new file called elixir.factorial.beam. So beam is just another name for the Erlang virtual machine. The B there stands for the guy who wrote the first version of ErlangVM, and I'm not going to try to pronounce his name, just read it out for yourself. And the EAM stands for Erlang Abstract Machines. So files with .beam extensions can be executed by Erlang interpreter or Erlang virtual machine. So let's go ahead, take a look at it, and this is what a Erlang bytecode looks like, it seems. So obviously this does not make sense, and it does not have to. We just looking at how this thing goes on to executing. So once this file is available for Erlang virtual machine, it can start executing. You can reuse the modules if you are an IEX, not an Elixir C. I'm saying this again, this is not a recommended method. I'm just doing this because this gives us a look at the beam file that is generated. So that is how the execution thing happens. So while we're talking about Erlang virtual machine, we'll look more deeper into it. So what exactly does Elixir leverage? So before knowing that, if you remember, I'll just open up IEX again. You saw the Erlang/OTP and the version 22. So OTP is a middleware. Inside that is a lot of libraries. All of them are written in Erlang. So technically OTP was created by people at Ericsson because they wanted their application to scale, and they wanted it to communicate remotely, and they wanted it to be highly concurrent. So it seems they tried something with C++, which turned out to be a failure, and then for some reason they used Erlang, and it worked out very well for them. So OTP is a collection of all these libraries for concurrency, fault tolerance, and all that stuff, and it is very powerful. It is used in the telecom industry, but you can see in the recent years, it seems it is not limited to just telecom industry. Obviously, we're using it in Phoenix. So let's go ahead, take a look at OTP now. So when you take OTP, these are the main components. It consists of a long interpreter called Beam, which we commonly know as Erlang Virtual Machine. So that is the name, which I did not try to pronounce. That is the first version. I mean, the guy who wrote the first version. And then it seems the next guy also had the name starting from B. So a very odd coincidence, So that, firmly becomes Beam. But, again, try reading out the names for yourself. I'm not going to do it. So there's another Erlang compiler. And then over here we have the protocol for communication between servers and a distributed database server. As I mentioned, this thing was built for distributed and communication between these servers. So that is one thing. So now we cannot look deeper into that because those libraries are not really, open. We'll look at it when we build Phoenix application. That is the best way. For now, just take a look at it, or just knowing that it exists or what OTP is and what that consists of is enough. So the supervisor module, I'll talk a little bit about it. So supervisor is a library in OTP middleware, which was written, improved by developers over decades. And this is what is responsible for fault tolerance in the Phoenix framework. So when you say fault tolerance, processes fail. Take up any language, the thread executing might fail. So what happens when it fails is the whole application crashes down. So it seems that these guys at Ericsson did not want that to happen, and they built a basic version of supervisor which went on to be improved continuously. So this supervisor module keeps on looking at process. You can give it a couple of child processes to look at. So what this does is just keeps on listening to them, and if any of them fail, the supervisor module will try to reinvoke them, and it is successful most of the times. And it also has many strategies, such as you can stop the entire application if one of the process stops, and then restart it. That supervisor will do it for you. You just have to mention the strategy. So that is all for one. Or you can also say it that do not stop everything, just stop the process that are dependent on the one that failed. So that becomes many for one, and there are different strategies available. But you can see this power. You don't have to do anything when there's a failure. There's a module that can handle it for you. So these are problems that have been existing for many years, and OTP sort of like fixed them a long time ago in the telecom industry, and it is happy to see this coming to web frameworks. So that is OTP, and I just want to mention another module called task, which is used for parallel execution of processes. We'll not look deep into that, just know it. It is not listed here, and I guess it is better if you know the name. So that being said, let's look at the real power of Elixir. So the reason Elixir is getting a lot of adaptation in the industry is because it can scale over a lot of it can scale over different systems, and it is highly concurrent. When I say highly, it is very, very highly concurrent. So let's look at how that thing works. So when you fire up IEX and you look at this part, inside this square brackets there is something called SMP and then a number. So I have 8. The more commonly seen number is 4. So the number might vary for each and every one of us, but that doesn't matter. What that indicates is the number of CPU cores that are available for executing processes. So in my case, 8 cores are available. The more common one is 4, and it is easier to explain with 4 cores. So I made this diagram with 4 cores. And excuse me for my poor photoshopping skills, but I guess this will do. So okay, so let's just go and look at the diagram. So you have 4 CPU cores available for executing processes. First of all, the most important thing is Elixir scripts or programs. They do not run as threads like many other languages. they run as processes. And when I say processes, they do not run as, OS processes. They're much lightweight in, and they run in such a way that a single OS process can run millions of Elixir processes. So if you go to the scenario of very large applications like Facebook and many other applications where millions of users use it at the same time, look at this. Just look at this raw power. So I'll just explain and then you can feel it. So here I see a single OS process created, and in that OS process, for per every CPU core available, there is a OS thread created, and in every OS thread there is a scheduler. So when Elixir processes start executing, they just go on to one of these threads, which is free, and the scheduler will take care that they do not collide. And they are sealed from each other. They have no need to show their data to one another, and if they do, they have to pass messages. Every process has a mailbox associated with it. Previously there was just one mailbox for one thread, and it was later changed to every process can have a mailbox for itself, and then it can receive messages into that mailbox and respond correspondingly. So let's look at this again. 4 CPU cores available for use, a single OS process, and then 4 threads for each available core, and a scheduler, and you see there. So I said a single OS process can million, so maybe one thread can run a lot of Elixir processes. So you can see most of the time these things are free. So that pretty much accounts for the high concurrency and scalability Elixir can provide. You can already see it over. Let's consider a case for a single CPU core. In that case, how concurrency is managed is when a process is executing below a particular threshold or not responding, it is given multiple chances to get back up on its feet, and if it does not, the state of that particular process is pushed on to a suspended buffer, and the process is pushed back in the queue. So that is for a single CPU core, but in multiple CPU core you can already see this. The most of the time the processes don't collide because there's a lot of space available for it to execute. As I said, most of the times these threads might be free, and if it does get crowded, there's a scheduler to handle this stuff, and that process is followed, which I just mentioned, of storing the state in the suspended buffer and then pushing it back in the queue. That process is called preemption, just to so you know that. So that is how scalability works, and I guess let's just go back at what we did in this video. So we created a fact.ex file, we compiled it, we looked at the bytecode and it made no sense, but that's not the problem. And then we saw how it is executed in the ErlangVM, and we saw OTP, of which the ErlangVM is a part. We took a look at what is there, and we talked a lot about the Supervisor Module, and I also mentioned the task module, just keep in mind. And then we looked at the real power of Elixir, the scalability. Let's just go over one more time. We have 4 CPU cores available, just for an example, and that is the most commonly seen number in many systems. And then you have a single OS process, and then an OS thread is created for every available CPU core, and then in those OS threads you have Elixir process running. So that is pretty much what I wanted to say in this video. So that is just a very introductory thing to this in this video that I did mention about all of these things. There's a lot more to read. OTP has a large history actually. It was made open source in the 90s, and since then it's been developing continuously. All of these is just very introductory things, all of the things that I said. So I highly recommend that you do some reading about this, because this knowledge will always help you when you work with the functional language and you think of concurrency. This information, OTP and all that stuff, it will always work, and it will help you understand distributed systems also. So that is all I wanted to talk about. So this is where I'll be ending the video. So if you did like the video, give it a like, and if you want more content, just hit the subscribe button. On the other hand, if you think there are areas I need to improve, because I'm new to YouTube, I just love sharing what I know, and YouTube is a great platform for that. So if you feel like there are areas I need to improve, I'm okay with negative reviews. Just leave a comment and I'll just work on improving myself. And one more thing, if you did have a better method of calculating the factorial, do share it in the comments. We can always work together and become better programmers actually. So yeah, so that is all I wanted to say. So I'm okay with negative reviews. Do leave a comment if there's something that you need to say. On the other hand, if you did like it, hit the like button and please hit the subscribe button. So this is Minna Sylvester signing off. Until next time, keep coding.